All right, to the second point, here we go. Again, stop the video, work the problems. We have a survey of voters regarding a particular tax proposal, and the following results of that survey were provided. So you look over the table here. The number that favored, here's likely to vote, not likely to vote, okay? So get familiar with the table. I want the probability that when I choose a person from this group, it is likely they vote in favor. Oh no, likely to vote, I'm sorry, I gotta get my pen working. Likely to vote or they favor the proposal. So they are likely to vote or they favor the proposal. So the likelihood of voting is 240. Favoring the proposal is 150. So that's the number of ways, 150, right? That's the number of ways we can choose somebody that's likely to vote or they favor the proposal, right? But you gotta be careful. And that's why you should have kind of thought about the formula, because this is an or. And if you remember the formula way up here, the probability of A or B is the probability of A plus the probability of B minus the probability of both of them. So going back down to our problem here, here's A, likely to vote. Here's B, likely in favor of, but we have to back off the probability of favoring it and likely to vote, meaning that 100 there we counted twice, in the 240 and in the 150. So we need to back it out. Now, the total number of voters was 370. So total number of survey of voters. Okay, so I was right. 370, right? So you do your math. 240 plus 150 minus 100 is 290. 370 is the number of ways we could choose somebody. B, what's the probability a randomly selected person is likely to vote given they favor the proposal? So now they favor the proposal, all right? Well, if we're given information, the world can be different. Well, we know they favor the proposal, so here's my world right here. Favor the proposal. In this world here, those likely to vote is 100. Got a 100, right? The total number of people in this world, 150. So again, this was a conditional probability. What's the probability that a randomly selected person is undecided? The probability a person is undecided. Well, there are 50 people that are undecided. There's 370 people. I did not give you any information like the previous problem. So if I'm not giving you additional information, the world is what it was. Keep that in mind. Moving on. A bag contains 3 red, 2 blue, 4 green. A ball is selected, color is noted. The ball is returned. A second ball is selected, and its color is noted. I want the probability that we select a red ball first and a red ball second. Now the question comes up, are they independent, mutually exclusive? Well, think about it. They're going to be independent because the ball is returned. So when I return the ball, when I go for the second ball, the world is going to be what it was. Now I'm going to play like I didn't know that. The formula that you're familiar with is the probability of A times the probability of B given A. Well, the probability of A, getting a red ball first, is 3 out of 9. There are 3 red. There are 9 balls in total. In the second part, I'm giving you a condition, and that condition was a red ball was selected first, but the ball was put back. My world is still 3 red, 2 blue, 4 greens. In this world here, there are 2 ways to get a blue ball. Red ball second. There are 3 ways to get a red ball. There are 9 ways to get anything. So 9 over 81, or 1 over 9. Next question. Now this problem is a little bit tricky. You have to be aware of things, okay? If you read the problem, let's see. Okay, if you read the problem, we're trying to find the probability they're offered a job, right? Offered a job, right? Well, if they're going to be offered a job, 2 things have to happen. They need to have an interview, right? And they need to be offered a job. That's the tricky part. So the probability of being offered a job actually is the probability of being granted an interview and being offered the job. Well, that is, again, really, you have to be careful here. This is a tricky one. Being offered a job is getting an interview and at the same time being offered the job, right? Well, that's just the probability of an interview. Sorry about the handwriting here. It's going to take me time to get used to this. Times the probability of being offered given you had an interview. Now the reason why I did this is because of that right there. Among those interviewed, that's information, the probability of being offered a job is 0.25. So the probability of being interviewed is 0.1. The probability of being offered a job knowing you were interviewed, 0.25. So the probability of being offered a job in general is 0.025. That's kind of a tricky problem, all right? Likely not to be on a test or nothing, but it's to get you to think. Next question. Back to the old colored ball problem. Read it over. In this particular case, when we choose the first ball, it's being put on the side, and then the second ball is being selected. So these are definitely not independent because the second ball is the choice of a second ball is going to be in a different world because that world is going to change based upon what happened in the first, right? Now, the question is, what's the probability we get a red ball first and a green ball second? So the probability that, I'm going to put it this way, red first and green second. That is the probability of a red first times the probability of a green second, knowing you got a red first, okay? Red first, all right? So red first and green second, here's your formula. The probability of a red first, 4 out of what? 7 ways, right? 4 ways to get a red, 7 ways to get anything. The second one, we have a condition. That condition is we selected red first. The ball was not put back. My world looks like, 3 red, 2 blue, and 1 green, right? That's my world now because the red ball was not put back. Well, in this world here, there's 1 way to get a green. There's 6 ways to get something. So, 4 over 42. Next problem. A bag contains the following numbered discs. So look at the bag. 1 disc is selected. I want the probability a 3 is selected given a gray was selected. So a 3 is selected knowing it was gray. Well, so I'm only looking at the gray disk because I told you a gray was given. In this world here, there's one way to get a 3. There's 5 ways to get something. 1/5. Next question. The probability of an even number given it was white. So even knowing it's white. So again, we're only looking at the white disk now. There are 3 in total. There's only one even number, so 1/3. Again, just going over this conditional probability stuff. I'm given the number selected was at least a 5. So I'm looking at, I'll circle these, at least a 5. That's my world. How many of them are gray? 3. How many do they have? 4. Now, let me erase this. So I'm going to hit my button, get my eraser out. And I'm going to erase this right here. Okay, so give me a second here. All right, get back into it. The probability the disk is gray and the number is at least a 4. The disk is gray and the number is at least a 4. So we have to be at least a 4, and it's got to be gray. So there's 1, 2, 3, 4. 1, 2, 3, 4 ways of getting that. There's 8 disks in total. I did not give you any information. The word given is not part of this question here. That's why I actually put 3 givens and then I threw one at you. Because a lot of times the students will assume the number is at least a 4. No, it's asking you for gray and number 4. You got to be careful here. Okay? Do you think the events selecting a gray and selecting a number at least 4 are independent? Do you think those two things are independent? Selecting a gray and selecting a number that's at least 4. Well, if you think about it, selecting a number that is at least 4, there's 5 out of 8 ways to do it. Now, if you select a gray disk, okay, then what happens is the probability is changing, because if you have a gray disk, then 1, 2, 3, 4 out of 5 chances of it happening known as gray, meaning if one event affects the other, and the event here is selecting a gray disk, it will affect the probability of getting at least a 4, because if it's gray, at least a 4 is 1, 2, 3, 4 out of 5. And 4 out of 5, right? That's different than just selecting at least a 4. So they're not independent. What's the probability the disk is white or the number is odd? Simple counting problem. White or odd. So white, 1, 2, 3. Here's an odd. Here's an odd. So let me erase that. That'll be the easiest thing to do here, right? Gotta choose my drawing. Gotta choose the eraser. Let me erase this right quick here. It's getting too messy for me. So let me redo it now. Here we go. I need white or odd. 1, 2, 3, 4, 5. There's 5 ways to get something white or odd. There's 8 ways of something happening. Now, suppose 2 disks are selected with replacement. If 2 disks are selected with replacement, what's the probability you get a gray first and a white second? Well, if you're putting it back, you're starting over. So the probability of gray is 5 out of 8. the probability of getting a white is 3 out of 8. Independent events can be multiplied. So 15 over 64. For the second one, I'm selecting 2 discs, but I'm not putting it back. So I don't have this independence. Remember, when you put something back, you're starting all over. If you're starting all over, you have independence. So when you have independence, you can multiply probabilities. But if you don't put it back, then the probability you get a gray first and a white second is the probability of a gray first times the probability of a white second, knowing you got a gray first. Well, the probability of a gray first is 5 out of 8. There's 5 gray discs, 8, right? The probability of white second, given you had a gray first, well, you know one of the gray discs is missing. It doesn't matter which one, there's one missing. There are 3 white discs. There are 7 discs remaining. So 15 over 56. Now here's a problem that is very common on the final exam. I worked one in class. We have a committee. We want to form it from 5. We want 5 people to be on the committee. We're going to choose from 4 teachers and 7 students, and we want the probability that we get 3 teachers and 2 students on our committee. That's what we want. We have a formula for and, but again, if you can count your way through a problem, count your way through the problem. How many ways can I get 3 teachers, 2 students, divided by how many ways pick 5 people, right? Denominator is just in general. When I formed the committee, I didn't say I needed so many teachers and students, right? I just need 5 people. But I'm asking the chances of getting 3 teachers and 2 students. Well, look at the numerator. I need 3 teachers, right? I need 2 students. The teachers come from 4 teachers. The students come from 7 students. I start to count. 4, 3, 2, 7, 6, right? But there's no order. Since there's no order, I have to divide by, I pick 3 teachers, 3, 2, 1. I pick 2 students, 2 times 1. No order. We do our math. 28 times 3. I do my math right, 24, that's 684. My numerator is 84. So look at that, I'm going to erase it. Well, actually, I'll put the denominator over here, right? I need 5 people on the committee. That's what I need to do. Now, I'm not distinguishing between the teachers and the students, so there's 12 people. Start to count. Right? 12, 11, 10, 9, 8, right? Once again, there's no order. You're just on the committee. I picked 5 people. 5, 4, 3, 2, 1. Now I'll start canceling. 5 times 2 is 10. 4 times 3 is 12. So 99 times 8 in this one, right? 99 times 8. I'm sorry, let me put it down here because I want my room for my denominator. 99 times 8, 72, 79, 84 over 7, 92. So there's your answer. It's not a difficult problem. You just have to realize that there's 2 counting problems. And you need it. These are 2 basic counting problems. There you go. I think that is it. These are some additional problems that might help you on the exam. Okay? So good luck.